Denis Jannot. I'm director of field engineering at EMEA, in EMEA for Solo.io, and I'm going to speak about this multi-cluster pattern with Istio in particular, and I'm going to really focus a lot on demos. So I'm using some slide at the beginning to introduce the concept, but I will really do a lot of different small demos there so that it's more interactive. And feel free to interrupt me if you have any question, if anything is not clear. I'll be happy to clarify that. So let me just go in presenter mode. And now I will jump directly. So basically what I'm going to do is I'm going to do a lot of demo that we have in a workshop. And we are going to run this workshop again in the near future. So if you're interested, you'll be able to join. But the idea, I will jump directly in this part here, where I'm going to speak about the different way you can deploy Istio on multi-cluster. So obviously one way is what we call the shared cluster or shared control plane, sorry, where you have just one control plane and you have two Kubernetes clusters and you have pods running on the two clusters. This model, we don't see it used quite often because first of all, you need a flat network. And also, if you have an outage on this cluster, then you lose your control plane and the other services will not work correctly anymore. And so the most popular way is for multi-cluster is really using this replicated control plane model, where you have different Kubernetes clusters and you deploy Istio control plane on both clusters. It can be 2, 3, 4 or more clusters. And then the advantage is obviously you don't need a flat network. If you have an outage on one cluster, it just impacts this specific cluster. But on the other side, it's a lot more complex to implement. And I will go through what are the common challenges there and the way we can handle them. So the most common challenges, and there are a few more, are about federated the trust and identity. And I'll go through that deeper in the next slides. And also how you allow the communication between the clusters, how you can also manage access control globally, how you can manage failover, these kind of things. So that's the topic I will cover, and I'll try to do, demonstrate some of these capabilities in the next slides. And what I'm going to use is a project that we have launched at Solo.io that's called Service Mesh Hub. That as for the goal of Service Mesh Hub is really to make it easier to manage Istio across multiple clusters. We started with Istio and we are extending the capability to other technologies like AppMesh and OSM, but definitely the big focus here is Istio. So I will not go deep here into how Service Mesh Hub works because, as I said, I'll go through the demo and it should be quite clear in a few minutes. But as I said, I'm going to really go through the different challenges, and I'm going to start with this federated identity. So here you are probably all very familiar with the way identity works in Istio, but I'm going to go through that very quickly again. So you have CA certificates that is used by Istio so that it can sign the certificates for the different services that are running in the cluster. And that's allow each service to have its own identity based on the service account that the pod is using each pod is using. And the beauty of Istio is that you can quite easily have encryption between the services using mutual TLS. And Istio is like handling the complexity, rotating the certificate, which is something that is really not straightforward to do if you don't have Istio. And when two services need to communicate together, they come with their own identity, like I described, based on the service account, but it's quite important to understand how it works. So each pod has like its identity in the form of a SPIFFE ID. So the SPIFFE is like a standard that means secure production identity framework for everyone that is used in Istio. And a SPIFFE ID is in this kind of format, like SPIFFE, trust domain, and workload identifier. And in Istio, a SPIFFE ID is like SPIFFE, the trust domain that you use when you deploy your Istio cluster, NS, the namespace of the service account used by the pods, SA, and the service account name. So that's like the give you a unique SPIFFE ID. And it's important to understand that because when you deploy Istio, by default, the trust domain is cluster.local. So when it comes to multi-cluster Istio, then that can become very challenging because if you have multiple clusters and let's say you have like pods on these different clusters that use the same service account name in the same namespace, then there is no way to differentiate these two pods. So when you want to tackle this multi-cluster Istio problem, or you want to deploy Istio on multi-cluster in the right way, the first thing you need to do is really to have like different trust domain on the different deployments. And that means that then like this pod running on one cluster has an identity that will be unique across all the clusters. As soon as obviously you have like different service account for the different pods. The next challenge after that is when these pods want to communicate with this pod here and you want to have like a mutual TLS, now they have their unique identity, but they are not able to validate that identity because, as I said before, the certificate used by this pod has been signed by the control plane here, while the certificate used by this pod has been signed by another control plane, and each control plane has its own CA certificate. So what we need is that we need a common identity. So we need like a common root cert. And then that's one of the first things that you get with Service Mesh Hub is that you have this concept of a virtual mesh. And when you create this virtual mesh, what Service Mesh Hub will do is that it will create like a new intermediate certificate on each cluster. And it will sign this intermediate certificate with a common root cert. And then this intermediate certificate on each cluster will be replacing the CS cert that is used by Istio on each cluster. So at the end, you will have a certificate chain that looks like the certificate of the pods, the intermediate certificate, which is unique on each cluster, and a common root cert. And because we have a common root cert, now it will allow one service on one cluster to be able to validate the identity of a pod in another cluster. So that's what you get like when you create this virtual mesh. I already created the virtual mesh in the environment we will use for the demo, so I'm not going to focus there. And I'm going to go back to access control a little bit later as well. So the first thing I'm going to do here is really to do a quick demo about how I can now have this cross-cluster communication. And for that, I deployed like 2 clusters. Basically, in fact, I have 3 clusters because I have one cluster where I have Istio running here on the left, which is called cluster 1. Another one here called cluster 2, where I also have Istio. And another one that's called management, where I have Service Mesh Hub. But this could run also on one of these clusters. I just put that in a separate cluster so that you see it's not mandatory. And as you can see, I deployed the Bookinfo demo application on both sites, on both clusters. The only difference is that the review service has only V1 and V2 in this cluster, while it has V1, V2, and V3 in this cluster. So as you probably know, I'm sure you're already familiar with the Bookinfo application. So here, if I send a request here, I will have just like no stars or black stars. And if I send a request here, it will be like no stars, black stars, and red stars. So if I jump on this demo environment here, and I'm trying to reach here this product page on the left. So it's just this one here. If I refresh this page, you see I just get like no stars or black stars, because obviously I send the request locally and I didn't configure any cross-cluster communication. Now, if I want to allow this cross-cluster communication, Service Mesh Hub makes that easy with this abstraction called traffic policy. So in the traffic policy, what I will say is that when when there is a request sent to the review service on cluster 1, I want a traffic shift to happen where I send 75% of the request to the V3 service on cluster 2, 15% of the request in cluster 1 on V1, and 10% cluster 1 on V2. So you see, it's very simple way to define this cross-cluster communication. So if I just copy that and paste this in my terminal, now if I go back here and I refresh, most of the time I should get red stars. See, first I get red stars here, red star, black stars. I can get other stuff, but most of the time I will get the red stars, because obviously the rule is like I get 75% of the time these red stars. So what's interesting is that it was very easy to set up, but behind the scene, Service Mesh Hub has created a lot of different Istio objects that are needed for this communication to happen. So you have obviously a virtual service that looks very similar to the traffic policy I defined, where you see the different weights. But here you see the destination is like, there is no notion of this is the cluster, because Istio is not aware, of this other cluster. But you have this host name that finished by cluster2.global, and .global is a special suffix that you use when you want to do cross-cluster communications. Then you need to have like a destination rule that defines the different subsets that I use here. Then you need to have a service entry that tells Istio how to reach this service in the other site. And obviously here the address is the address of the Istio Ingress Gateway on the second site. Then on the second site, it creates an envoy filter that basically will track all the communication coming with cluster2.global, and will replace this suffix by cluster.local. So that's the communication seems like a local communication. So everything then can happen normally with the local destination rule and so on. So again, the idea is really just that with a very simple abstraction, I can make this cross-cluster communication happening. And then with the Service Mesh Hub UI, we can see the policies that we create, like this one. And you see here like the percentage of the workload that is described in the policy. And we can see also like the workloads that are impacted. And that's an example for a traffic policy, but you can also create like, for example, here I allowed the review pods to talk to the rating pods. And you see I defined different traffic targets. And I can show you that, in fact, here. So I already created that before the demo, but you see you have the traffic policy like I described before, but we have also another abstraction, which is called access policy, which is a kind of cluster aware authorization policy, if you want. But here, instead of just using traditional service account selector and stuff like that, you can also set up some different clusters. So here, basically, I say I want the service account used by the Bookinfo reviews pods on cluster 1 and the one on cluster 2 to be able to reach any rating service on any cluster. And that has been translated by the local authorization policies. And then if I go back to the UI here, it displays as well, based on the current workloads that we have on these clusters. These are like the current source pods and the target pods that they can reach based on this policy. And you can always also like go to this debug mode and see the corresponding authorization policies and service entries and destination rules and so on. But that just makes it easier with this higher abstraction that are cluster aware. So this example was really about showing you how you can do like cross-cluster communication. And another use case for that is if I want to manage failovers. So let's say if I am not able to reach the local review service, I now want to reach the review service on the other side. So again, I'm going to jump on the demo and configure that. So the first thing I'm going to do is that I'm going to remove the traffic policy I just created here. And then I'm going to create a few objects. So one is a traffic policy that will define outlier detection. So I will be able to tell that I want basically to have this outlier detection. If I have like more than one error in 10 seconds, then I want to eject the target for like 2 minutes. And so I'm going to apply that here. And basically it will be translated. When I do that, it's translated in two different Istio objects. So one is like a destination rule here on cluster 1 and a destination rule on cluster 2 for the review service. And you see the outlier detection that is similar to what I just like defined in the traffic policy. And then the second step is to create a failover service so that we define, what are the services that are behind this new host name that we define. So it's kind of like defining a highly available host name. So if I want to reach the review service and I want to make sure that I will be able to reach the review service even if one of the backing service is not available, I will do that by creating this failover service. So let me just try to copy and paste that. And again, when I do that, basically what Service Mesh Up does is that it will create an envoy filter so that it will replace the DNS name I specified here by the local and the remote cluster. And it will also create a service entry for this new host name so that it's known by the mesh. So I could just stop there and I could say, okay, now if I want to access this, then I would go to the product page service and I will modify my microservice here. I will modify my application. And instead of sending my request to reviews, I would send the request to reviews failover. And basically the application will be aware that it's now targeting like an highly available service. But I can even make it transparent so that here I don't want to modify my product page service. I want this highly available service to to be in place without changing anything in my app. And that's something I can do easily. I just need to configure another traffic policy where basically what I say is that when a request targets the reviews service, I send it to the reviews failover so that it becomes transparent. And so I'm going to just create that. And again, if you think about what it does in terms of Istio, it just like create a virtual service. And the virtual service is just like requests going to reviews are now sent to the highly available service. So to test it out, what I can do is I can just like make these review service on the local cluster. I can make them unavailable by just like adding a sleep command. So if I do that here, they are not now unavailable. But if I try to access my app here, that should still work. You see, it still works. I still get like, oops, just the time to make it happen. I can still see, I can still access my review service. And I have a way to prove it. In fact, is that if I go to, if I look at the logs in cluster 2, I should see requests coming. So that's just prove that the requests are really going through this second cluster. So here I am on the second cluster, and if I continue to refresh here, I should start to see here, I see more requests coming here. So again, it was really easy to set up the failover, and I'm also able, like it was the case before, I can go here and I can see what policies I have in place, and I can see the failover that I just configured here, and I can see the backing services for the different failover, and a few other things that I didn't describe before, but that are quite nice here. When I created the mesh, I enforced airbag globally. So it was like an option on the virtual mesh creation that I can show you here. So I created the virtual mesh before. Nope, it was just there. A little bit higher, I think. Yeah. So here you see the first time when I created the mesh in the demo, I didn't set the access control here, and I just did that to validate, the SPIFFE ID and all these things. And then when we do the access control part, we just modify the virtual mesh so that we want airbag to be enabled globally. And when we do that, what service mesh up does is that it creates some rules like that, some authorization policy with an empty spec. That means that nothing is allowed, no communications are allowed. And currently my application is working because what I did is that I already created all my access policies here to allow like the ingress gateway to talk to the product page, then to allow the product page to talk to the details and reviews services. And then, so you see, constructing all these different things that are needed. And then allowing the reviews to speak with the rating service. But again, it was just the reviews on this site. So that was allowed, but still this one was not allowed for the global communication. That's why what I said before is when I did this traffic or multi-cluster traffic here, I had to create as well this access policy to specify that I also want the review on cluster 2 to be able to communicate with the rating service. So yeah, I mean, it was just like an overview of what you can do with Service Mesh Hub and how it can really simplify multi-cluster communications. And I just kept some time for answering questions. So if you have any question, I'm happy to respond this question now.
Thank you so much, Denis.
You're welcome.
And would you be able to pass me back the host rights so I can continue to?
Yeah.
Thank you.
Okay.
Any questions for Denis? Matthew, are you in the call? Would you like to unmute? Is that possible for you?
Yeah, I was on mute.
Great.
Yeah, I had a question. I'm a novice at all about Istio. So I was looking into multi-cluster stuff, and I was wondering, there's Kiali, which offers like visualization of the traffic that's flowing, and also with traffic policies that split percentages of certain traffic to certain destination. Is there something like that as well in Service Mesh Hub? Because there is a lot of information apparently in there about which services are backing which rules, and I was wondering if that is available as well.
Yeah, that's a very good question. So that's the next item in the list of what we are tackling. So we are adding some new stuff in Service Mesh Hub. One thing that we are adding is like a global airbag, so that you can define, who can do what, who can create these access policies, who can create these traffic policies and stuff like that. And the other thing we are working on is a global, global telemetry, or global metrics like you just described. So that's something we are working on, because currently you can have Kiali on your first cluster, Kiali on the second cluster, and you can use that to visualize the communication between services on the same cluster, but you cannot do that for multi-cluster. So we are working on having like a global telemetry, and that will be part of Service Mesh Hub.